There's your data flow. Exactly. All right. Well, hey, thanks everyone. It's 6 o'clock. I think we should get this picked up. I'm not sure if anyone else is going to be making it. But if they do, I'll run. If you see me running out, it's because someone's feeling that they're stuck at the elevator downstairs. Thanks for coming. Today we're going to have Ananth over here. He's going to be talking about streaming data analysis, right, Ananth? Yeah. He's ready to go.
Yeah.
So Ananth is one of our more senior engineers. Did you say your architecture and custom development? Would that make sense? I'm going to say yes. Right now he's focused.
Yeah. I've been working with data applications for over 20 years, and I think in the last 2 years I've started working with the cloud technologies, got into Amazon, and now GCP. I've been working with all the tools all around the place. I've got Amazon certification, working on Google certification right now. That's my to-do for the next one.
So right now we're getting
you're not?
Right?
Okay. I thought I was sharing it. No?
No, not anymore.
Not anymore. Okay.
So this is on
YouTube.
I was already.
I've learned my lesson when I've gone to edit the videos afterwards. It's like, no one needs to see that. I'm keeping it on this till he's ready.
Okay, let's see. Now, does it work?
Yeah, I think so. So I'm going to make you presenter. You ready?
Yeah.
Okay. Awesome. That should be going out to work.
So that's
Take it away. Thank you.
So that was a quick introduction of me. I've dabbled around with a lot of Google products, including Kubernetes. I've worked with their app engine, and then I've played with Dataflow, PubSub, and a couple of their products. Today we're going to talk a little bit about data streaming and what it means to you. So before I started on this, thinking about processing, I was looking, and when I talked to Matt and said, I'm going to do a data streaming analysis, I went back and said, what does streaming actually mean? Right? So there were different concepts that I had to dabble with. So one of the things that I ran into was between batch and stream. So when you talk about batch processing, you're actually talking about a method in which you're waiting for data to be collected over time, right? Time interval could be a day, could be an hour, could be a 15 minutes, but you're actually waiting for data to be collected over time and then sending it down to your data collection stream. Then that processes the data and then puts it into some kind of an analytical storage, right? And then you look at the data. So the batch processing is more of a concept of you're waiting for something to be collected over time, push it. It's mostly in intervals of time, and it's not real time. So there is always a lag that is between batch runs. There's always a lag time between getting your data in. When you're talking about streaming, before we talk about streaming, so the batch processing has gotten better and better over time. And what people have started doing is running what we call as micro batches, right? So they're saying, okay, I'll do near real time stuff by running my batches in quick, small intervals, right? So I run my intervals in like 15 minutes, 5 minutes, or whatever. And then I'm actually doing something close to being a real-time system, but it's still running batches over and over and over again. And you run into issues like your batch size and what's your window of processing, right? If your batch size is too big and then your window is small, you will be running 2 batches at the same time, and you run into certain other issues. So then we move on to, so the second part of the processing was the stream processing. And this is where it got to a point where people said, what if I collect data in real time, push it to a system that is collecting data real time, and then I process it in near real time. When I say near real time, the reason I use the word near is there's always a latency between systems. So it's near real time processing, and then put it to a end system where you're actually storing the data, you're visualizing the data, whatever you're doing with that, right? So that's more of a streaming concept versus the batch. So I had to wrap my head around this concept before I even started working on anything with this one. So I don't know the slide. Sorry. So there were some business drivers that were moving towards streaming data from the batch data. So there were batch systems. Typically, most of the systems, legacy systems, used to be batch. By that I mean systems that were disparate, will not talk to each other. They didn't have any real-time connections between systems. They all used to be doing batch, right? So when you're talking legacy systems, those are the ones. Now, some of the newer systems started looking and saying there is a cost of me getting the data late, right? So if I'm doing a real-time analysis of let's say a fraud system, getting my data like half an hour or 1 hour behind is just as costly as getting it a day late, right? The event has actually happened. I'm not able to look at it real time. I'm looking at it and going, what can I do with this data? It's all becoming a more of a reactive system. I want to be proactive. So to build a more of a proactive system, I need to get the data into my system timely, right? So that's one of the business drivers. The other one is, I put it as cost of processing, right? So if you're doing big batches at one shot of time, then you need gigantic, infrastructure to run this whole data set, and the data set may be too huge to be run in one batch. So if you can spread that batch over time, which is what micro batches was doing, but if I'm doing more of a real time, I'm spreading that cost out to be running on my infrastructure all the time, right? So there's an advantage of doing that with a little bit of a real time system rather than doing it in batch. Then the scale of processing, right? This is very interesting. If you're doing some analysis, let's say with the logs data that is being collected, the amount of data that is being spit and the amount of data being collected is literally too huge to be doing anything with respect to batch system. So you have to think about streaming. You have to think about getting data in real time quickly into your system so that you're able to you're not waiting for this huge chunk of data to come through you, and then you are not able to scale enough to grab the data and process it in your system. So with that, I came up with like a few concepts that we had to wrap our head around. So when we are talking about a batch system, right? So you're talking about a data set that is bounded. So when you call about bounded system, you're looking at a finite set of data that you're working with, right? So if you're working with 100,000 records, even if the data is like 1 million records, it is still a huge amount of data, but then it's still a finite data that you're working with. That data set doesn't change over your time. But when you're looking at something that is working in real time, then you've got to think about something called unbounded. So when you're thinking about unbounded, your boundaries, there is no boundary to your data set. Your data set is constantly getting data in, right? And then you're constantly processing the data out. So your data set happens to be one huge infinite set, right? But then you have to think about how I'm going to make it process the data around unbounded data sets, right? So the two concepts are a little different. Again, when it comes down to processing, right, between batch and stream, I gotta again think about the same thing. when I'm doing a batch processing, I'm always having a bound data set. I have a fixed data that I have to process, running through my system, I'm done. Right? But when I'm doing stream, again, what am I actually doing? We are actually taking the real-time data and then processing through. When you have to look at saying, have I processed this data before, or how am I going to put this into chunks of data that I'm going to be able to analyze down this time, right? With that, I came down to two other concepts that became very critical. There was something called event time and processing time. So when I'm about to collect a data that happened on an incident, right? So let's say I'm doing a logging system. I'm collecting logs from, let's say, a compute engine that is generating this log that's getting down to stack driver. Let's say I'm doing some custom logging that's coming down to my system. The data that's being generated on that compute engine, right? It's generated at a certain time. That is your event time. So that's the time at which the system that generated the data captured that time. Now, processing time is the time at which your system sees the data, right? Your system could see the data a few minutes later, a few hours later, uh, it could be even a few days later. So some things to remember, like if I'm on a real-time system, I'm expecting event time and processing time to be the same, right? So I'm looking and saying, hey, you're generating an event, I'm getting the data. There are a lot of things that can go different about that. There can be latency in your system. There can be people that are not sending data to you real time, but collecting data. So one of the examples that I can think of is like if you have an application that is collecting data on the phones, right? If you have a phone application that is sending data to your system, and the person is going on a flight, he's going to turn it to an airplane mode. In that time, he's still going to be collecting events, and still going to be having data with some timestamp on it, but he's not going to be able to send anything to you until he reaches his destination and he turns on his internet and then starts to push the data to your real-time system. So there's a little difference in that, and I had to dabble with a little concept there. The reason is there may be systems that may be talking about two different times here, and that's why we need to just get our so when I get this data in, there was a few things that I also looked at and said there were analysis done with no time sense, right? So I could be doing an analysis with just data that is coming in. I don't care about what time the data had generated. So I just collect the data, I just aggregate the data, I just show the data endpoint. Like so those are systems that doesn't bother about time. And when you're building any kind of system that's collecting that data, you don't have to worry about any kind of time dimension in your data. Approximation systems are something that is that goes a little one step ahead and says, if this is the data that you are being getting, there have been complex models to say what your next hour of data will look like or next day of data will look like. You've looked at predictive models to build your analysis, but these two things usually have a time dimension that is a little static, right? Then comes a little bit of windowing dimension analysis, which is this is where you're looking and saying, I'm looking at data slices with the data coming in, and you're looking at data and saying, can I slice it down to an hour of data, and that's my windowing concept right there, right? So I'm looking at that, and I could be doing windowing on either the time at which the data was generated or the time at which I see data, which is processing time versus eventing time. You want to add anything here?
What's an example of why you do windowing? Trying to get like an average over a minute, maybe the data that's coming in, or
right. So you're trying to get so you're like, let's say gaming stats, right? So if they're doing an online gaming and all of you are in the same game, you have something called leaderboards where you want to show who is leading, who's not. Those kind of data requires me looking at the last minute of data to determine who is the winner or who is generating the most points in the last 1 minute or 2 minutes, right? That's one of the typical examples I've seen of using event time or with a windowing concept with either event time or processing time. Right. So when we capture time in my data, there was let me step back a second to this slide here, right? So when we do the dimension analysis, we are looking at these 4 different types of analysis. The first 2 dimensions are not what we are a little bit concerned with. We are a little more concerned about the windows and windowing concept in streaming. The reason being, you're getting an unbounded data set, right? So you're getting an infinite amount of data. It is tagged with a date and you or a time in a picture, right? So you want to use that time to see, build different sets of data on which you can do your analysis. So which brought me down to a little bit of this concept. This is a little advanced concept here. I want to throw it out there. If you don't get it the first time, neither did I. Right, so I had to go back and did some dabbling, and then went back and reread this. So when we are capturing time, we have to think about different ways of kind of trying to capture data in terms of the time dimension when you're doing the streaming analysis. So in there, you're looking at fixed sliding or session window. Let me see if I have a picture here. So this is a little bit of visualization of what my data kind of looks like and how I am looking at an unbounded data set and making it into a set that I can work with, right? So if I have data coming in from, the x-axis is your time dimension, and it's generating data over time, right? Key 1, key 2, key 3 is just an example of some data being generated out there. So you have this data coming in continuously. You are looking at trying to piece and say, I'm going to look at a 30-second window to analyze my data. The next 30 seconds of data is another set of data. So I'm kind of taking an infinite set, taking a time dimension, and trying to split it into a window of time where the data becomes a manageable set of data that I can work with. Did I make sense, or did I throw you guys off? So this when I talk about windowing, we are trying to make the continuous streams into pieces of data that I can follow. When I use fixed windows, I'm just saying when one window starts for 30 seconds and ends, that is where my second window starts. And that's where I start saying that is one set of data that I've already worked with. What's an echo? There's an echo. Are you guys getting an echo? I can hear an echo there, so I'm like, yeah. So then the second window starts right when the first window ends, and then the next 30 seconds is the window 1, and then after 1 minute, the window 2 starts. So continuously, I'm trying to put data into slices there, right? And this is a fixed window slide. So when I look at a sliding window concept, so this is where you're getting data. Your time axis is x-axis is your time, and the y-axis is your data coming through. Key 1, key 2, key 3 being some pieces of data that you're coming through. You're having window of data that is processing for a time where window 0 in this case and window 1 has an overlap. So I have a window 0 of about 60 seconds duration, but I start my next window at 30 seconds and go the next minute until 30 seconds. Why do I do this? I want to get a minute of data to do my analysis, but I want to run it every 30 seconds. Make sense? So I'm trying to now get statistics and doing things in that 1 minute window, but every 30 seconds. So I'll have overlapping windows. Now, this is, you might ask and say, oh, I have some things that I might have double counted myself in window 0 and window 1. The idea is we are showcasing a dashboard with some real-time data, which might be close or which might be close or near to what your actual final data is, but you're trying to show 1 minute of what happened in the last 1 minute of data, or what in your system right there. So this is a sliding window concept out there. And then the third thing is something called session window, and this is a little bit different. If I haven't I'm not here, the time element is a little skewed, right? So where I had fixed windows, every 30 seconds I was looking at data. Here I'm looking at saying somebody did something from key 0 did something for 30 seconds in window 0, and then there was nobody there was no data from him until window 1 started, right? Typically these are like sessions, right? If you're having session data, you log in into a system, you have data coming in, you'll have activity for that user for a short time, and then there will be an activity, and then there'll be an activity, but you don't get continuously the activity because the user is kind of on the system and off the system for different intervals of time, right? So these are the three windowing concepts that are used. Now, why is windowing important? Important problem of trying to bound my data set so that I can actually work with that data set. So to me, when I look at continuous stream, when I can use different elements of windowing and I can get data sets, now I'm working with a finite set and I can do stuff with it, right? So then it's kind of wrapping your head around saying I'm streaming of data, but the data and then work on it. That's my batch. To put it in a way. It got can say that this is the data I'm working with. I want to put a bound set of data. So this is the Windows concept, and this is the basics of a little bit basics of understanding what the streaming data analysis was. There are some advanced concepts that I don't want to get into. There was something called triggers, and there was another element. So these are things that talk about how and when the windowing is created and things like that. But I want to keep it at this because these are the concepts that will help us understand what we've built for our real-time system, right? Any questions at all? Or any concerns, any questions? So when I looked at, I then flipped it a little bit and said, so when I'm doing a real-time system, building it in GCP, what does my GCP ecosystem look like? This is the GCP ecosystem a little bit. Now, there are 4 parts to it. There is the ingestion piece, which is the piece that is actually generating the data and pushing the data to your system. There is the second portion of it, which is the processing system. The third portion is taking that processing system, analyzing it, right? And then, so you have three pieces to this. So you have a Cloud Pub, Sub, and Data Store. These can stream data into Dataflow. And these are all systems that can generate applications, can generate data and push to Cloud Pub and Sub, right? And so we can pick it up from there. Cloud Dataflow is typically your processing system that is based on Apache Hadoop, Apache Beam. And this does the processing into your storage on the right side. On the right side, you could be storing it either in BigQuery, which is your data warehouse. Thank you. Yeah, which is a data warehouse system, or you could send it through machine learning or to Bigtable. And then you can use then third-party tools or data visualization tools on top to see how your data analysis. With that, I just thought I'll just put a little bit. I was down here putting some slides on PubSub. But before we talk about that, do you want to do the demo, or do you want to talk about this?
Whatever you'd like.
So I don't have. I have a few slides on PubSub. So we've let's talk a little bit about the demo that we have done. So in this ecosystem, what we have done is we've taken a IoT app that actually generates some data and pushes it to PubSub. And PubSub actually then picks up the data, pushes it, and there is a subscription on the PubSub that the Dataflow subscribes to. That pulls the data in through Dataflow into BigQuery. And then we've done some aggregation based on a fixed window that we can showcase. Let's run down to that.
Okay, so this demo was based on something we did a few months ago for this group. We did something on the IoT. Let me see if I can find that deck so we can see what the diagram looks like while we're preparing here. Let's see. Right, so this is kind of what we're looking at today, and you can go back and find the details on that from the blog posts and the videos if you want to learn more. But we thought we'd reuse this application since we had it, since it could generate a decent amount of data, even with a small number of people. What we ask you to do is, if you go to the URL that you see on the screen to the right, share this over here. And what happens is when you go to that URL.
Can we take a picture of it?
Sure.
Yeah, if it helps.
Yeah, go for it. I can have it on there.
Pardon? Yeah, so when you go to the URL, it's going to load a web application on your phone. That's all it is, it's just a web application. It's not installing anything nefarious.
It's going to see our location and send it to the Russians.
Turn on location services when you get on there before you go on that.
Yeah, it should ask you about location. Please enable it. As soon as you kill the browser, it's not going to be collecting anything. If you get to that page, you should see a register button. This was all part of the demo last year, so please click register. It might take a few seconds for everyone in the room to become registered. Excuse me. I shouldn't be doing this talking like this. Once you're registered, you should see the heart to the right kind of change flash. If you're not seeing it flash, just refresh the screen. There's a little bug in the JavaScript. And then you should be good to go. Actually, I guess I could always demo that up here as well.
Are you going to shoot your computer?
Let's see.
Man, I think we registered me.
So yeah, I think I have it out here. Yeah, I have it here. So
Okay,
you should see something like this, where you should see thingy, and then you'll see a few letters on the left. That's your registration, something that identifies your unique phone, right? And then you have a configuration version where you should see a reset on the right here. Since this is my this is my desktop laptop, it won't see the heart here. Otherwise, you'll see a heart on the right side. It should be blinking, so it's then sending data to us.
Yeah, so if you see in the heart link, you're in good shape.
What if it's not blinking? Do reset?
Just refresh it.
Just refresh it.
Yeah.
There's a bug.
This is.
Refresh it?
Oh, it did for a second.
Yeah.
Stop.
Oh, there you go.
Okay, so what's happening is every time that flashes, it's sending a piece of information to Cloud IoT Core, which I'm not going to go into too much right now. But basically, all that information that's been aggregated from all these phones is being put onto a Cloud PubSub topic, and then Ananth's going to ingest.
The Cloud PubSub is going to be ingesting it. Bring up here. So once you get on there, there is a subscription on pops up that is actually pulling this data. And then Dataflow, we are actually running Dataflow on a streaming, on a direct stream to run it on the subscription. And then we are pulling it and pushing it into BigQuery. So now that we've got people on there, let me see if we've got all the registrations out there.
Right. Oh, okay.
Yeah, I got a couple of people. Yeah. So this is the IoT page where this is where when you go to that website and you click on, and then you're starting to register your with me. This is the device I manage. The first part of the thing is right. What we have here is like we talked about. This is the shake telemetry on PubSub shake telemetry, and then the app ID. The second one is your location, which is your latitude, longitude, and then we are also using acceleration, X, Y, and Z acceleration. We have an accelerometer that we are grabbing your data from there. That data is being pulled in.
Lots of data you're saying?
Yes. So the more you shake, the more data you send. Yeah.
Well, that means if you're accessing it from the computer, then you're not getting.
You may not get much data, but you could. Yeah, you're right.
It depends. But some
It
of them
depends.
have a way of simulating.
Yeah.
We were the other simulator where you could go change your location on your browser, and then it would send the data, or you could simulate a XYZ, whatever, right? A little bit of movement, and
Again, depending on the browser, some of them have got brilliant drag and make it flip and do all that, and it sends the right data. It's kind of cool.
so what we have here, this is a topic that we put up, and this is the topic telemetry data flow, right? This topic has a subscription. So when I go here and look at subscription, I don't want to delete it. Let's see. So here, when I say, oh, here, subscriptions. So this is the subscription called telemetry data flow that we created out on that topic. So you're sending data there. I'm using the subscription is actually looking at the data and then making it ready for data flow to pull in. I have data flow running already in Google Cloud, right? So here, this is the data flow. So little interesting things I want to show. One of them is on your right-hand side, you have a panel. This panel talks about all the different things, I still hear an echo. It's kind of.
I'm sorry to hear it too. It almost
Yeah.
sounds like it's coming out of your computer from where I'm sitting.
Well, it's a microphone. If you mute your computer, it might go away.
Is it? No, I still hear an echo.
Turn your volume down.
Just talk loudly.
Yeah.
That works for me.
Yeah, I mean, it's like I'm hearing an echo and it's kind of disturbing me. Okay. So on the right side, you see the job, and you can actually run your data flow in a certain region, right? So you can set it to run in a region. Then on the bottom here, some interesting stats here is like it tells you how many worker nodes are running. So under the data flow is it's bringing up compute engines and then running them, running the nodes on those compute engines. So here you can see some stats about that. On the bottom, you can see what's the resource that is running on it. So it's a 4 CPU resource that's running on that. And then down here, you should be seeing, yeah, here. So this is your read-write bytes. This tells you, so you can build counters that tell you what can. So here, you can see that these numbers are changing. This will tell you that your data flow is still running and picking up the data. So here, I have two different streams of when I inject the stream, we are doing two things with that data. One is we are taking the data as it comes and throwing it into BigQuery as a raw telemetry. So I have a table here that
For your history.
yeah, where is history?
Left. Underneath compose query, there's a string.
Oh, okay. History.
So there's a
That was actually I had saved queries on here, so I was looking at how it should be. How do you? I'm sorry.
but you're doing more than
Says sets here. So let me, one is data set. I created a data set that actually counts. So this is where you have we capturing the user agent on which your the app is run data, and then here is down there is the device. So grabbing all this information here. This is just a raw table. There is no that if you had off and you were sending some data to us, all the way in the latitude, longitude, accelerometer, cause this whole thing to kind of not capture the data. So we had to kind of make it nullable out here. So this is my raw table where I'm getting the data.
you just save one query with everything in it. That was
No, I had 3.4 queries that I saved.
that's okay.
Uh,
You need to disable the other.
yeah. Okay. So if you can see my screen down here, I mean, I just limited it to last 1,000 records, but let me put a better timestamp out here. So I start, well, we are already on the 28th, so.
27.
No, by UTC date, we're already on the 28th. So that was actually throwing me off as well, that so we are seeing some data here. Now let me 4 p.m. 5, 6, 6:30. So it's about 2:30 my time here.
One 1:30 maybe?
Yeah, 7 minutes.
Change your lights in.
Oh, okay. So that could be it. So this is all the data this is the raw data. So when I look at your user agent, it has whole lot of things. What's your browser that's running? What's the OS that's running it on? We have your latch longs. So we were trying to plot it on a chart and say where you're located at. We can do that. And then we have the accelerometer. This is the data that is generated when you shake your phone, move your phone. So it should have some data in there.
As long as you can enable access to the sensors.
Yeah, so there you go.
Yeah.
So there you're seeing some data here. This is X, Y accelerometer data right here. And then on the right, we have the device ID. So this is the device that is actually generating the data out here. So this is your raw telemetry. And when I look at the data, let's go back here for a second. So this is the first the data takes two paths through my data flow. The first one is I directly inject it into PubSub, translate it to be saved into BigQuery, and then push it into there. On the second one, I'm doing a little bit of a difference here. There, what I'm doing is I'm doing the windowing right here. So this is where I'm saying I'm gonna do a window of I think it's 2 minutes that I set up. So 2-minute window, I collect the data and then I do a count by OS, and then I send that data to a different table, and then I'm trying to grab that data by the time, as well as the counts of requests being sent. So let me show how that goes. So the table I have here is a timestamp bound, and then I'm grabbing the operator right here. Bug in the code that doesn't count everything into one bucket. So we've seen some data being duplicated over buckets. But essentially, when I try and get data from here, again, like what is one? Okay, so this is oh, I have a group by. So there you go. So what you're seeing now is we've got Windows Phone. Oh, we've got Windows Phone finally. Somebody having a Windows Phone.
That might be a test.
And that's probably Mark right here. He was one of the guys.
I did it
I
on here.
think I know who it is. Yeah.
Oh, you're logged on from there. So what we've captured is we've captured the OS and then the request that is sent by OS, aggregated it over that, and the query does the aggregation. But what I wanted to share with you guys, if I look at the raw data that I was, the grouped data that I was capturing from breakdown of OS. So I'm actually capturing the data in Windows. So this is what I was talking about, a fixed window where I'm looking at this timestamp. On that, I'm saying this iOS has one request, and so on and so forth. So this thing has a little bug in here right now. We are putting the timestamp onto every time the data is recorded. So it almost looks like it's the same time that the data is collected. But actually, what is happening is Dataflow is running it in windows of 2 minutes, collecting your data and doing aggregation over it. I'm going to show you your code in a little bit here, so that might be a little more interesting to you guys. So this is your data flow right here. Before that, I talked about how data was coming from your phone to PubSub, subscription, down to data flow to BigQuery. Any questions there before we get a little bit deeper into the code here? So I wanted to showcase a little bit on the data flow side of things, right? So what you do in data flow is you have a very simple in and out. You start by building a pipeline that pulls data from an input, and that's basically it. In the middle is your processing. When you're building your pipeline, you can give it an options. Those options include where your input is coming from, where your output is going to, what's your runner, and things like that. Before that, yeah. So you have to first run this pipeline with a set of options on the top. So this is your first part of your data flow right here. And then the next one is just to create the options and create your pipeline. Now with that pipeline, I can do multiple things with it. So the first flow that I have is your straight flow that reads the message, transforms the in-read message into an IoT data format. An IoT data format for me is just a representation of your data, right? So my representation of the data is I'm getting a timestamp and a user agent, and I'm also getting an IoT, the position on it and the accelerometer data, and I'm getting a device ID. So this is the data that I'm getting, that telemetry that your application is sending. The app engine,
Right. So
the
Cloud IoT.
Cloud IoT is sending to me.
Yeah, something JSON payloads, basically.
Correct. Then out here, so I have to. So this the first pipeline is taking that message, translating it to an IoT data format, and then saying, I didn't. I'm just going to format it to push it to BigQuery, to a table row. Push. This is your overall pipeline. This is what it looks like, right? If you dig a little deeper, you're looking at functions. So the first function you had to look at is saying, if I get a message, I have to get the. So I'm getting the payload of the message, and I'm taking the payload and converting it into a JSON, right? That's your first transformation that you're doing right there. The next one is your IoT to table format, right? So you're taking an IoT data format and converting it to a table row, and this table row is what the format that BigQuery understands to push it there. So you're building a table row here, and then you're creating a table row with all the inputs coming from your IoT data format and translating it into a table row format. Once you get it into a table row format, see here, IoT to table formatter, then you're actually then writing it to BigQuery set output. This is doing is taking a data element that it's in the pipeline, converting it into the written into.
Right. What I think is jet clear for a second
Yes,
is
sure.
that with the data load we've had today, one standard VM node is good enough to handle everything we're throwing at it. But one of the things you get with data flow is that it scales automatically depending on the load. So if you throw enough data at it, 2, 3, 5, 20 nodes will spit up automatically. And then they'll scale right back down when the load decreases. So even though you're seeing one program here, what happens is once this is executing in the Google environment, it looks for functions such as these that can be serialized and sent over the wire. So this actual piece of code here gets turned into a byte stream that gets sent to all the different nodes along with a portion of the data. They work on it independently, then aggregate it all back together for you automatically. Right? So you don't need to handle any of that serialization, any of the acknowledgements, anything. It's all just done for you. That's all for that.
Oh, yeah, that's. So what I've done is, so you have your input. What we did was apply windowing concept over that. So what we did was we said from the data set that I'm getting, create a fixed window. Sorry, this is my windowing. So what I'm doing is I'm creating a fixed window of data, and this is where I'm using a concept of the thing saying I'm going to create a window of 2 minutes size, and that's my data set that I'm going to push to this particular transformation, right? So I'm getting the windowed input is nothing but is data set. For every 2 minutes, there is one of that data set created, and then it's pushed through the transformation, right? And then when I push through that, this is the count. So this is what it's doing is adding a timestamp to that fixed window. What we were trying to do here is every time 2 minutes passes by, there is one of these windowed input that goes through your pipeline. You have to put a timestamp to that and grab that timestamp and put it into and saying, for this time, you got this data, right? So every 2 minutes later, you would say, this is the data I got. Let's say now, 2 minutes later, that's the data we got. So we wanted to timestamp it. So we were working with C dot output with timestamp. We got there, but I think we're still having some challenges trying to tie it down.
We have day jobs as well. Right?
So yeah, and then we have this transform here. I wanted to showcase this one. So what I showed you earlier was just a straight transform. It just takes data, just manipulates every individual element into another element and throws it into raw telemetry. Out here, we are doing what is called as we are doing an aggregation here. So what we're doing is we're getting a collection of IoT data that is coming in, right? And then we are adding it to a number called batch. We were trying to get the batch number and timestamp. So this is still working code. Just ignore that. But what we were essentially trying to do here is we were extracting just the operating system out of the user agent, right? So this is where I can look at one element and say, for each element, I'm just going to get the operating system part of it from your user agent, right? So I'm doing some kind of a slicing there, and then I'm doing a count for each OS that I'm getting. So I'm extracting all the OS, getting it into a list of operating systems, OS that comes in through your user agent. And down here in the count, I'm counting and saying how many different data elements came through that for that OS in my user agent, right? And so this is a kind of a transform we did with this one. So once we do the transform right here, we push it then through push it back into BigQuery. For BigQuery, there was something I wanted to just share a little bit. When you push to BigQuery, you have to create a table row, and you have to create a table row with all the different elements here. But when you want to write it, you want to also give it a raw schema to it, because I think that's the requirement for writing into big data is like you need to give it a raw schema here with the different elements, and then what elements you're giving, and this is your actual table row that is your data element right there, right? So that's so we have so this showcases the two different uh, flow of data that I've shown out here. The left hand side being the straight, the right hand side being the windowing concept into counts.
So this data flow picture, how does it get generated? Like after you have your job defined, like this picture that you have.
Oh, right. So this one, you have to actually start your data flow job, right? Once it starts your data flow job, it takes about 2 to 3 minutes to provision your provision the compute engine on which it is going to run, and then it's going to then start and build this one automatically with your flow. So you're not doing anything here, but you can look at each one and you can split and see what your different things look like. So the code that you looked at right there, it's the same different elements that you're seeing here, and you can also look at how much data is flowing through that. You can build some advanced concepts in here which we couldn't get to. One was logging. I think we did some logging here, so we did
Did you
some.
show did you deploy your code? Did you deploy this job or didn't? I stepped out for a minute, so I might have missed it. But did you
Oh,
get
I
to-
didn't.
Did you get to the deployment of the code you just showed this?
No, we already had it running, but let me show you that.
You can do it now.
We can do it now. So if you guys are on for seeing this, any questions before I go into that?
No.
Into Josh's question. Okay. So when you stop this job and this is a live job that's running, you have two options here. It will either you can just say cancel the job and don't do anything with the processing, or you can just drain all. That means it'll finish processing everything and then it'll kind of shut down, right? So I'm gonna just I'll do a cancel. I mean, it's gonna be faster.
Kill
If
it.
Yes.
Kill it.
Yes. I was gonna say that's where I want to go. I want to say I killed this job.
Murderer.
I killed this job on Google.
Was that running at the same time?
Yeah, this is where I was.
We've
Running.
always
Change the job name.
So what we're doing now, we're joined by Josh today, who actually does this for a living, as opposed to us amateurs over here.
Yeah.
Was there anything that we missed out that you would have added?
No, I just say, how do we get from looking at code to running a job?
Okay, so once I have this code ready, yeah. So what we did was we built it into a jar file, right? So we did a Maven package. Hopefully I haven't changed anything in the code that kills that. And then this whole thing is now the demo guards are alive.
What made you have us to say that they should choose Maven over Gradle? We all know Gradle's.
Then what I do is I run it as
Wow.
class path.
Probably
Maven. Gradle.
Gradle's still better. I'm biased because it's all you can really use with Android.
What's this ID you're using, or is it, what is?
Which one?
Is it an ID?
So I'm using IntelliJ
You can
IE.
do
So
yes, I think.
this is an IntelliJ IDE that I'm using here. So this has So you could be using Eclipse. I just use this for having master here who can help me with stuff if I get stuck.
Uh,
Right.
just have some-
That was really my choice of
So
using
you
this
use
tool,
it.
right?
IntelliJ, don't waste your time.
The
Don't
balance,
IntelliJ,
yeah.
press the button, pay for the license.
Okay. So I wanted to talk about two concepts here before I show him the running thing, right?
One
So
thing at a time.
when I built the Dataflow job, I don't have to run it in GCP all the time to do my debugging. I can actually set a runner to be direct runner, and you would actually run it on my local machine, right? So that's the beauty of Dataflow is I can have it running on my machine and test with some test inputs here, and then I can then run it back into.
Do you
In
have a way of
GCP.
visualizing, like if you were seeing on the GCP that you were just running?
When you're running local, you just have the logs.
Just the
You don't,
logs,
yeah, you don't have all those beauty.
Right, it's built for just a very simple
Correct.
integration test and nothing more.
So I can put it as direct runner here, and then I'm actually running the data flow right now on my local machine right here. So this is where I would debug. Now I can be sending messages here, and it would still be picking it up from PubSub. The reason is I have actually installed my Google tools here, and then logged in and run it in that project. So essentially, I have to set it up to run in my project, and then I'm good to go to run it on the local machine. If I have to kill this guy, so there you go. So this is all your debug statements that we put in here. As we were debugging, we said, am I inside this function? Where am I getting stuck? So we just put like inside this function. So yeah, it's a typical developer thing. That's our debugging stuff. So this is where we had the stuff there. And then I think if you're pushing some data or anything, it would show up here. But if I have to actually run it on GCP, so this is, I'm going to kill this one here. Right? I just have to change the runner to a Dataflow runner. And then what it would do, hopefully this job is dead. Yeah, so this job is done. So it'll take about at least 2 to 3 minutes before the job actually comes up. But then this is where the code is, the jar file is being pushed to a temporary location in GCP, and then that's the one that's getting executed in Dataflow.
And when you're in a production environment, how do you deploy to that to do this?
So in production, you wouldn't do it this way. You would actually have a Git repository from where you would run it from. Right? So that's your that's a better way of running it. This being just a example, I'm running it.
So basically, you'd be deploying to a virtual instance, which is a Java runner in that itself, or are you actually having to stand up
No, so Dataflow is completely a managed solution.
I walked in an hour.
No, I know.
So I don't know
No, Dataflow is completely a managed solution, so you don't have to provision anything. All you're doing is you're managing your code and trying to then build that code to give it to Dataflow, and Dataflow does the rest of it.
Okay.
So when you pull up Dataflow here, it takes about 2 minutes before it starts to see. I was thinking there was an error in running of my code when it gets stuck at this point, but no, it's still.
Is there any sort of callback that you can set up so it actually Google Cloud will actually say back to your executable down here on the local machine, hey, go ahead, look now.
Yeah, it does. It does. So at the end of it, what it'll tell is like, oh, your Dataflow job is running. Yeah, there you go. So it says your job is submitted, and then once your job starts, it'll even tell you a command that you can execute to kill your job.
Okay.
Yeah. So it does that. Ideally, you don't have to run it this manually. You would run it out of
The other thing you can do is you can set up templates. So when you submit it like this, instead of actually running it, you give it another argument that says upload all the files to a bucket, create this framework around it, and generate a JSON file that you can then reference later and say, now execute that JSON as this job with this many runners.
And then you're doing it more
And
as
now
a
you're
service
just-
as opposed to an actual executable.
Exactly, you can put that into Cloud Functions, CI/CD, whatever you need.
Right, and it'll stand up everything for you, basically.
Yeah, it's completely unmatched.
So let's see if it is running now.
There it is.
Can you run?
Yeah, there you go.
That's,
See that?
I've
So
not
that's
done
your
that.
job
You've
running
done the
right there.
prompt, for sure.
So out
Not
here,
this, because I would just put it in 6 years.
it'll tell you. So this is a cool thing that you don't see.
So that's the way I usually look at it, because you don't want it, it's not a long lived game.
Yeah, it's a job.
Yeah.
So this is something that you see that the current workers was 0 when the job was submitted, and it just went up to 1. And as your load increases, it knows to throw more processors in there.
That sounds
And
like a
then-
challenge. I don't think we'll do it, but if anyone's up for it.
What's the challenge?
Let's see if we can scale that thing.
Yeah.
No max workers.
No,
Well, I don't have
you
max
know
workers
about
on
that
here.
now, Andrew, right?
Yeah, I do, yeah.
So I haven't set that one up.
I don't think we'll do
Some
it.
you're gonna incur a lot of charges to run it.
No, no, this is nothing.
This is nothing. No,
This one.
Oh, we're really trying?
Well, I was.
I was trying to push more
Once
data.
again, I'm the only one, Andrew. Thank you.
And what's the URL? I'll start.
Oh,
okay. Yeah,
it's,
again, you came in late, right?
Sorry, my apologies.
Not a
Oh, yeah, I
problem.
love it.
Let's see if I can find it.
Well, it takes a minute.
I like
for
where it
to-
is as much as you complain about it.
GCP.
We're not gonna
only
get
have
more
that on
than
the
like
Wi-Fi here.
5 or 6. We're not gonna get rid of it.
See, where is it?
it was on that other slide.
Does it this way? It's in my screen. Pretty sure it's this.
Yeah. So right
There you go.
here.
Okay, let's go have fun.
So sometimes I mean down here, once the job is submitted, it also tells you to run this command
Well,
to
it tells me
kill
that
the
this
job.
phone is old because mine
So,
flashes a lot slower than
So
it
do you have to have the SDK installed?
Refresh.
first?
yes. So you need to yeah, you need to have SDK installed to run it locally. I don't think that is a requirement for you to run
There
it on if you're running a
But I'm sure it helps because then it
So-
also gives you all the
So
libraries that you need when
okay,
you're
so
doing
let me put it this way. So when you're actually starting to build a data flow, you would run it locally. So to run it locally, you would have to have your SDK and everything installed, because you would say runner equal to direct runner, and it would be running locally. So you can see if you got some errors, if you got some exceptions. I mean, exceptions all throughout here. It's easier for you to look at this data and fix it.
That's another way of looking
Then
at
when
it.
you're
Yeah.
pushing it, but when you're running it in GCP, no, you don't have to have SDK installed.
Yeah, it's pretty slow.
The only thing is, even if I'm running it in the local, I'm actually accessing PubSub, and then I'm pushing it out to BigQuery from my local machine.
You're right.
So for all that, yeah, I need my SDK installed. Yeah.
Oh,
And then you have to be logged in into
I ended
your
up buying the
account.
paid one because after a while.
And then in the right project. I made the mistake of being in the wrong project.
Oh,
No
yeah,
data
I should
coming
fix
through.
the bug.
I'm like,
Yeah,
oh,
group chat.
what's going on?
Why?
It was actually, we had a similar
So it's not
PubSub in
just-
my one of my projects,
Oh.
and
then
the other project
that
which was
setting
throwing IoT
that
data
you
was a
can
different
convert
one. So I was
as
on this project looking for data.
to MMS.
exactly on that.
So the idea is.
So you want to be very careful.
Just sending pictures, you know?
Do you
But
have
with
Compute Engine also
Android
have
and
developments
Windows.
tonight,
No, what?
or do you need it?
There will be one. If you go to Compute Engine, you will
Yes.
see the instance that's running.
Okay.
He didn't set it up, it's all done automatically.
Oh,
We work
like-
here.
So
Okay, go
we
ahead.
should see. I mean, you're saying we should see it here, right?
Yeah, if you go to Compute Engine, you'll see it.
4,000, yeah, right.
There you go.
Yeah,
That is your
I
compute
like
engine
it.
that's running. So as it scales, it automatically brings up the compute engine out here and throws it out here, right? And it scales, and then it scales down, I believe, when you have very less data. So the moment it's,
Let's see if we actually gave it even a play.
let's see, stats,
Yeah,
CPU,
20%.
20%.
We're doing something.
Yeah.
I love being able to track where it's at.
That's just
coming
Red
tomorrow.
to show up on your screen at all, or is it just the-
No, it didn't show anything at all.
Oh, maybe we did break it. I don't think so.
No, we didn't break it.
No, the scale's still down there, yeah.
No. I just lost my premium Stackdriver account. I was working with Stackdriver. You get 30 days free for Stackdriver, so I was using that to look at some of the stats. Over the weekend, I lost the premium account and I had to pay for it. So I didn't go with Stackdriver stuff.
So it's expensive, right, Mark?
Forget that.
Yes, Mark. Now that I have a cloud, you can't say no, right?
Apparently
Mark?
you just said, come see me in the morning. I'll get pregnant.
Oh, there you go. That's something.
Oh, okay.
There you go.
Oh,
Yes.
wow.
So,
If you tried harder, it might have happened.
Right.
feeling that's what you
it might have been because I think
Yeah.
that's the big blip out
Yeah.
there. Yeah.
It makes
Because
sense.
after
Figure
that,
out like
yeah.
2%. Scroll down
We
just a
made
little
it
bit. I'm
down.
curious what size
No.
instance it shows for you. Just scroll down like a. There you go. Perfect.
Yeah, it's a N1 standard 4, so it's a standard 4 CPU, 15 gig memory, but I think we are barely even blipping that.
Yeah.
Yeah, did you choose
You
that
can
size or
always
was that
give
given
it
to you?
Okay, no. So when you run it, it standard. It puts a it allocates a standard compute engine for you,
Yeah.
but you can
Standard
override
form,
it
yeah.
to set it to a minimum that you can run it. Yeah. So this is it. And in the code, I wanted to show you one other concept out here, which is a little interesting when you create Dataflow. Is you got to extend a Dataflow pipeline options class to give it additional input. So some of the pipeline has its own inputs that you can give, right? Runner is the first input that I gave. I set the runner to local direct runner. I'm running it on my local machine. If I'm doing it Dataflow runner, I'm actually running it on the cloud, right? So that's my first parameter I'm giving. But that's a standard parameter that is offered by Dataflow pipeline options. Now, if I want to do custom options, right? What I said is I wanted to give it a subscription name, and I wanted to give it an output BigQuery, right? And I want to give it different elements there. I have to build an option class that extends from Dataflow pipeline. Once I create that class, I can get custom input, and I can make it a required field, which is what is here, and I can also say default it to something. So I don't have to give it every time, but I can override it by saying minus input pops up, and then I can use a different subscription. So this is one of the best practices that they recommend is do not just hard code your parameters, make it a parameterable job. Oh, he's looking at Andrew there. No. So this is another cool thing here because you can actually run it on different test data sets, but then just give it different parameters and then be able to run it in production as well. So that's from the code side. Those were some of the things that I can show you about. The transform functions are very generics heavy, so I just want to warn you guys that it's all function stuff. I had to get my head around function pointers. Everything is a function pointer in terms of transformation, and I learned that there is nothing like a count of a string or a count of an object. You're giving it an input of type something, getting an output of type something. It's always a transformation over a type that you have to give it. And if it doesn't, if you give it a wrong type, you'll start to get some weird errors, and those errors are really you pull your hair trying to build this one. Because I had one error where I was getting an output of key value of string int, and I was actually the next transform I had was a key value of string long, and it's for the longest period it's like, no, you're not giving me the right input. It gets some weird errors. Where it throws the errors is when you build your pipeline here, you'll see some red marks and say the next apply can't take from the previous apply. I'm like, this this is all what I built before is what I built now, but it is very finicky on the data side.
So,
Right.
so basically what you're saying is that you have to put you really, to save yourself, you probably have to put in wrappers beforehand that actually do a type check.
Yes.
before
Well,
this.
not
That way,
really
you know,
that.
this will take a int and this will output a log.
Yes.
This will take a log and that.
Correct.
These wrappers.
Correct. So if I look at this
Protect yourself.
P transform, right? I'm giving it a P collection of IoT data, and I'm getting back a P collection of a key value of string long.
Oh my.
Okay, and you have to be very specific about saying I'm transforming the P collection of IoT data to another collection of key value of string long, and you have to get that definition. And then when you do the expand function, you have to say what is your input. Input is your P collection of IoT data, and the output you're getting is the P collection of key value of string long, and your whole function sits in here. If it all doesn't match, no problem at all. It doesn't even compile. So running it is out of question. So yeah, and you don't have to be type safe. It is.
Could you not
Gets you.
get around this with a language like Python, which is not?
Okay, so I dabbled with
Python.
Python a little bit. It's probably a little easier to do it in Python, but Python has its own little challenges around data. It's very flexible in terms of data elements. So you could be translating one to the other and not knowing what errors you make. So you have to be very careful. And the when I was up at Google training for Dataflow, they showed me everything in Python, but they didn't have any data types in there. So when you're playing with a lot of data and you're not very careful with your data types, you get weird data in the end, and you don't know what you're fighting. Are you fighting your code, or are you fighting the type that you worked with, right?
Python, you can use Python, but it still has some limitations. Java's going to give you a little bit more options within Dataflow, and it's still faster.
And Java is
I mean,
faster, right?
It's certainly easier to write Python than it is Java, so there's no question. But they're still coming out with updates on the Python library. So
What about using something like a
It's
Scala
giving you
or
notification
Kotlin?
here if you type
That'll
I was gonna say, I wanna see this rewritten in
Right,
Scala.
Another thing you can do.
Scala has its own seems to be doing the networking thing, so I'm not sure it will work out well.
Sometimes apps.
Well,
will-
it's
so-
It still has the
I
entire.
Sometimes
Java
apps will have
library.
like the ability.
Right,
to-
it does, but a lot of
Click
the,
bubble,
if you look at it,
and there's a bubble
what came
that
from
doesn't
Scala
seem
is there. I mean, that's why you've got everything as a P collection where it's heavily typed, is because it's all going across the network, right? All of these things can be serialized independently to multiple machines. So Java 8 and definitely Java 9, you can feel the influence of Scala coming back,
Yes,
right?
Java 10 now with var.
Right, exactly. So all of these things are coming back into the mainstream. So I don't think Scala is necessarily the way to go with this, and Google definitely doesn't support it. You might get it working, but
Right, you'd have to do something, you'd have to have some fun with it, with bringing in a
Right.
Java-based library into Scala or into Kotlin.
yeah, Kotlin
Kotlin would probably work,
because
but
it's a transfer. Right?
Yeah.
Yeah. I don't know.
Just I don't know, a question to make sure I'm on the same page. It gets back to your schema that you defined your BigQuery table, right? So if you define it as a long versus an end, the reason it has to be a long, you have to transform it to a long, because it's just literally pulling from the serialized. So it's expecting a specific number of bytes. They get slammed into the table definition. So if you have the wrong type, you actually have the wrong data because you're shoving the wrong
Right.
content.
On BigQuery, you'll get a different error. But what I'm talking about is between the transforms, it doesn't like it. It doesn't do
Oh, so
automatic.
this is not shoving in
This is
BigQuery, this is
between the
transforming.
transforms when you're pushing it. You would expect some kind of a translation to happen, right? Automatic translation to happen. No, I found out the hard way. now.
There is some. I
Yeah.
think it's coming back to your point. If you're old enough to remember having to worry about network by
Yeah.
order and things like that,
Yeah.
that's what we're worried about.
Yeah.
It's, that's the key thing. Sorry, maybe you don't.
No, I don't know where I fall in, man. I'm close to you guys, but
All of a sudden, they're tracked away, right?
Yeah, there's a reason it can seem frustrating when you're first doing it, but it kind of makes sense as you dig into it. And the examples on the Beam site are actually pretty good. Most of us here have gone through all of those to get where we are.
So there was a caveat on Apache Beam. So if you're doing Dataflow, you want to be very careful that you're using Dataflow 2, because Dataflow 1 was an implementation of Apache Beam into the Google SDK itself. So you use some of the Google libraries to do Dataflow. But then when you go into Dataflow 2, everything is based on Apache Beam, which is an open source, right? And that open source is very, it can support multiple runners, which means you can run it on various different platforms. It's extendable because the model is very simple. It's input transforming an output, and your input output is what you can extend to and give it various adapters. So it's a very extensible platform. So when you're building the Dataflow, you want to be very careful that you're building it on Dataflow 2.0. So let me show you that as well.
And the documentation there can be confusing if you're going through it.
So any documentation on Google site, just throw it away.
Yeah. On the
just
Google
throw
site,
it away.
like,
No,
you're right.
for Dataflow, just throw it away, because whatever is on the Google Google site
and the pain point
is
the
Dataflow
the very
1.0.
top of the page. It says this is for 1.4. If
Yes.
you're using 2.0, go to this link instead.
So
and then it has all the documentation still there.
So
that's wrong.
when I was building all of this, all I had on the right side was Apache Beam, nothing else, because everything else it said, oh, you can do this. And when I tried this on Apache Beam, it's like, no, it's changed a little bit. You can't do that. And everything is, it can throw you off a lot. So if you look at all the libraries here, so I think this might interest a little bit here, that we are using just the services for BigQuery here,
You can do that.
right? And that's all we are using out here. Probably PubSub. There should be some for PubSub as well. But most of this is org.apache beam dot whatever runners or dot SDK dot whatever. Right? So if you're seeing something from Google, then you're not in Dataflow 2.0.
Yeah. You think
It's
they'd
literally just that
emphasize
one little line at the
one
top.
little star in blue on blue saying, hey, you're using the wrong version.
No, go down a little bit. You'll see that.
That's it.
No. If you take any example, it'll tell you that this is example 1.0 in red, and it'll tell you for 2.0 there is no example out here. You go there. So
no, it is. Just go to the.
So go here to know what you are building, and this is probably a little better site for you to understand. But if you're actually looking at documentation, go down certainly to Apache Beam.
If you're on this site, you're on the right side.
This you're on the right side here. So I don't know. I think the folks on the online cannot see.
How big of a headache was that, Andrew?
Yeah,
Trying to figure it out.
It was terrible. And then it was fun.
So this is the place you want to go to, right?
Okay.
This is the place you want to go to, and this is the documentation. They've got a cool get started here. They talked a little bit about Scala too. There you go.
Yeah, that's
Somebody was
from
talking
Spotify. It's third party.
Okay. And then I think some of the things I've never tried out a lot on the Apache Beam was that you could run it on, I believe, Flink or Spark, but I don't have experience in that. So I never tried all of those. Apparently, when you build, if you build your data flow, you should be able to run it on all these 5 platforms out there. And then if you go to documentation, there's you can get lost here a little bit here, but this is you can talk about designing your pipelines. This is what I just talked about a little bit. I was trying to put this picture in. So this is your basic input output, running it through P collections. Everything is a P collection inside of Dataflow. And then this is a cool site. I thought it talks about merging, transforming. It gives you a basic idea of what you're doing with the data flow, and then there's detailed documentation out here.
We're getting close to 7:30. Respectful of everyone's time.
Yes.
Thank you, Ananth, for doing this. That's awesome. You really picked up something that's within that side of your wheelhouse. You did it. That's nice. Next
Thank
month,
you.
we're going to have, I think it's Casey from Signal FX is going to be demoing a product that he wants to show us because no one else is volunteering. And after that, we might be doing something on Flutter.
Yep. Flutter
We're
and
doing
Firebase.
something-
If someone else wants to do one, you can do one, but I'm free for May if not to do Flutter and Firebase.
Okay, so you're May, Flutter and Firebase, because I've got
What
you
is
locked
Flutter?
down. June.
Flutter
June
is
open.
Google's new cross-platform mobile framework.
So think, just like Xamarin.
Yep.
Xamarin or React Native, but it's called Flutter.
Okay, cool, and that's why it's so.
Yeah. So
Okay, I'm just-
Jared's been looking into it, and now we're going to do a demo of it in a couple of months, right? We're actually working with the code and everything. And then we've got an open slot in June if anyone wants to demo a product, if you want to present on something that you've been doing in Google that you think would be of interest to everyone else, just let me know. Drop me a line. I'll be happy to set you up.
Yeah.
Okay, but with that, thank you very much for coming. I'm sure there's still sandwiches left. Help yourself.
There are.
Take some with you.
Yeah, I don't want to throw them
And
out.
that
So
hammering sound, it sounds like somebody is hammering on the next floor above us.
Yeah, they're installing
yes,
that.
so we got lucky.
At first I thought I was like going a beautiful mind and everything.
I'm not crazy.
I'm not crazy.
They start after 5 or 5.